Hi everyone, welcome back to sisyaclass YouTube channel. So in today's class we are going to learn about hydrocarbons. I hope you have followed the last session in which we have learned about general organic chemistry. I hope you have learned about the nomenclature, how do we write the names, what are the features, isomers. You have covered that, different types of electronic effects, because you need that information in order to answer questions in hydrocarbons also. We have already covered all the organic chemistry chapters for their 12th standard, so you can revisit those sessions also if you are confused there. So let's begin everyone. Let's start with our hydrocarbons, and before we start I want to give you one information regarding sisyaclass, then you will begin with our session. Okay. All right. Let's start. So I want to tell you about our 1 year maths course for grade 3 to 10 at just rupees 999. For the entire year, you will get the maths course for just rupees 999. So you will find that per day the cost is less than 3 rupees. All IIT, NIT experts will be teaching you. Your entire CBSE, ICSE and state board syllabus will be covered there. Okay, so it will be a great help to you. It is entirely for maths. If you want to learn other subjects, then we have other courses also. You can check them out by downloading our app. Okay, so this is our scan code. The maths course is going to start from May 5th. Okay, and if you download our app and you enroll in our course, then you can take help of Sysya AI also, in which you will get text-to-text out solving, speech-to-text out solving, image-to-text out solving also. But you have to enroll for the course in that case. So please enroll. Tell your brothers and sisters if they are interested. It is for grade 3 to 10. Okay, so this was one information I want to give you regarding sisyaclass. Now let's begin with our session. Let me introduce myself. All those who are following the EAPCET series, we have completed so many different chapters. I hope you have solved some questions based on them also. You have to practice more and more questions. We are covering some concepts in the class. I'm telling you all the things, but after that, practicing questions, seeing what type of questions have been asked before, are they discontinued or not, that is up to you. You have to practice more and more questions in order to do that. Okay, so let's begin. So my name is Nidhi Narwal and I have 6+ years of experience teaching JEE NEET examination, and in today's session we are going to talk about EAPCET. So let's talk about this competitive examination, not too very different from the other engineering and medical examination. In here also we have to solve questions MCQ only. We don't have to show them the entire thing. So the syllabus is also almost same. The pattern of question is also almost same. So we are going to learn questions based on hydrocarbons today. Organic chemistry chapter, how we are going to cover this chapter, as we have done the other chapters before this. We are going to understand some important concepts and then we are going to solve questions based on them. As simple as that. So I want everyone to participate also. When we solve questions, try to answer them. Try to solve them yourself, and if you don't know the answer, you can see how we are solving it here. Okay, so let's begin everyone. Let's start. So what are the topics we will discuss today? We are talking about hydrocarbons, so we will learn about alkane, alkenes and alkynes, their properties, their reactions, everything. And finally we will talk about our aromatic hydrocarbons, and we will learn about the concept of aromaticity also. You already know that as well, but we are going to revise that. Okay, that how do we identify aromatic compounds, and how do we understand this is non-aromatic or anti-aromatic. We will learn that, and all the electronic effects that you have learned in the last session, if you have attended it. If not, then you can revisit it. We are going to apply those concepts in today's session as well. So try to revise everything. Everything in organic chemistry is interconnected. You will not find anything in isolation, that if I don't read about GOC I can solve hydrocarbons. No, you cannot. Okay, that is why we have done that before. All right, let's begin. Let's start with the first part. Let's talk about alkanes. First of all, what is the general formula of alkanes? These layman terms we are not discussing. It is CnH2n+2. You already know that. What are the important things? Please see. So we can prepare alkanes from alkyl halides by reduction using zinc HCl. So you start with some alkyl halide. Let's say RCH2Br. any random alkyl halide you can start with, and you react it with zinc in the presence of HCl, and you can prepare alkane. So that halogen will be removed and you will get your hydrocarbon, alkane. Okay. Next, Wood's reaction. Please make a star mark here. Very, very important. How they will ask you the question. Sometimes they will write the entire reaction and they will ask you to identify it. Name reactions are so important. They will ask you the name of the reaction itself. Otherwise, they will give you the starting material. They will give you the reagent also. They will not tell you it is Wood's reaction. They will ask you the product. One more type of question that can be asked from Wood's reaction. They will give you the product directly and they will ask you what was the reactant by which we have formed this product. So these are the three kinds of questions that they can ask you from Wood's reaction. Very, very important. We will solve questions based on it. Okay. So finally, from carboxylic acid, again important, coal-based electrolysis. So again, they will ask you what is the final product. So always focus on name reactions, revise them multiple times because you will find direct questions are asked from there. Let's see the reactions once. Okay, please see. So you have your alkyl halide. We were talking about the first reaction, alkyl halide on reduction in the presence of zinc HCl will give you alkane. Okay, please see alkane. What are we doing? We are just removing this chlorine and in its place we are adding hydrogen. Addition of hydrogen is reduction and we are forming alkane. Done. This is your Wood's reaction. It is specially used for the preparation of symmetrical alkane. What type of alkane? Symmetrical alkane. Can't we make unsymmetrical alkane by using Wood's reaction? You can, but the percentage yield will be less. So what type of alkane we are preparing predominantly by Wood's reaction? Symmetrical alkane. Okay, which has even number of carbon atoms. If you want to prepare unsymmetrical alkane, we have other different methods for it. Wood's reaction is not preferred. Why? Because the percentage yield will be less. Please remember that. That is one limitation of Wood's reaction. Okay, so you are starting with this alkyl halide. You are just going to connect the two alkyl groups together. So you can write this reaction in this way. RBr, RBr. One example, in the presence of sodium and dry ether, just remove the halogens and connect the two alkyl groups together. That is all you have to do. And this will be the symmetrical alkane that you will prepare. If you start with some two different types of alkane, you will form the product there also. So there will be different types of products formed in that scenario. Two will be symmetrical alkanes, one would be unsymmetrical. So let's say you wanted to prepare one special kind of alkane, you cannot select that. Selectivity will be less, percentage yield will be low, and we will not prefer Wood's reaction in that scenario. We will cover one such question also in today's class. Okay. Next, what is decarboxylation? Removal of CO2. Decarboxylation is removal of CO2. What are we doing here? Coal-based electrolysis. Again, a name reaction that makes it important. How are we going to remember it? Okay. So this is your acetate ion, right? See, we are doing electrolysis. So there will be some reaction at anode, there will be some reaction at cathode, and that is how they will ask you the question. So you have to remember what type of products you will receive at anode, what type of products you will receive at cathode, and such question has been asked before. So please note it down. Okay. So you will write at anode, what happens? Oxidation, right? And how do we understand oxidation? Loss of electrons. Okay. So at anode, oxidation will occur. We are going to start with two molecules of this acetate ion, acetic acid to be exact, okay, and we are going to remove one electron each from them. So what would be left behind? Two CH3 free radicals and CO2 gas will be liberated. So you have to remember what happens at anode. Hydrocarbon will be formed and CO2 gas is liberated at anode. We will see the reaction at cathode also, and they will definitely ask you this reaction. Okay. So now we have two free radicals. What happens when we have two free radicals? They will combine together. Okay. So these two free radicals will combine together and they will give you this hydrocarbon. So these two reactions occur at anode. Yes. So what happens at anode? Hydrocarbon is formed. Along with that, CO2 gas is liberated. What happens at cathode? Write that also. hydrogen gas is liberated. And if you have taken sodium salt here, what if we have taken potassium salt? Then according to that you will form your hydroxide. Since we have taken sodium salt, your product at cathode will be NaOH. What if they take potassium salt? You will write potassium hydroxide, simple. Please don't write sodium hydroxide if they have taken potassium salt. Don't cram. Remember the stuff, that what type of salt we have taken in the beginning. Based on that we will decide what will be the final product. If we are starting with the sodium salt, obviously you will not get potassium salt in the end, correct? So hydrogen gas is liberated, along with that NaOH. So these will be my products at cathode. Yes, so products at anode, hydrocarbon along with CO2 gas. Products at cathode, hydrogen gas and NaOH. And we have one such question in today's session. I hope once you understand this thing, you can answer that question yourselves also. Okay, see the next thing. Alkenes. How do we prepare alkenes? By dehydration of alcohols. Sulfuric acid is a very good dehydrating agent. What do you mean by dehydrating agent? One that removes water. Dehydration, loss of water. Okay, so concentrated sulfuric acid you have taken. You will start with this alcohol. From the alpha carbon, OH is removed. From the beta carbon, hydrogen is removed. So this is a beta elimination reaction. Yes. And you will get alkene. And if you remember, in haloalkenes and haloarenes, you have learnt about beta elimination reaction. Okay, so if you have not seen that session, you can go back to our YouTube channel. You can search for haloalkenes and haloarenes. There we have discussed about beta elimination and alpha elimination. You can learn that concept and then you can come back. Okay, but please try to understand the difference between the two. Beta elimination is more common and part of our syllabus. Alpha elimination not as that much, in which you get carbene. Okay, so what are we doing here? Beta elimination. From the alpha carbon we are removing OH, from the beta carbon hydrogen, and we will get our alkene. Okay, so this part is done. Now similarly we can also do dehydrohalogenation. What is dehydration? Loss of water. What is dehydrohalogenation? Loss of hydrogen halide. So based on what type of halide you have taken, that you will remove. So in this case we have taken bromide, so loss of hydrogen bromide. See, loss of hydrogen bromide. From alpha carbon you will remove bromide. From the beta carbon, one hydrogen, and you will get alkene. So this is also beta elimination, this is also beta elimination. Okay, so these are two ways in which you can prepare alkene. You can either do dehydrohalogenation of alcohol, you can do dehydration of alcohol or dehydrohalogenation of some alkyl halide, and such reactions are asked directly in your questions. It is so simple to understand. Okay, see the next one. Alkynes, what we can do? We can also do dehydrohalogenation of dihalides. This is double elimination. Why? Because we want to prepare a triple bond. In case of alkene preparation, you are doing dehydrohalogenation only once. Elimination was taking place only once. So you get a double bond. If you do dehydrohalogenation twice, if you do the elimination twice, you will get a triple bond. Simple. Okay. So we are starting with a dihalide. Dihalide, two halogen atoms are present. Okay. And this is a vicinal dihalide. The two halogen atoms are present on adjacent carbon atoms. If the halogen atoms are present on the same carbon atom, you will call it as geminal dihalide. We are not talking about geminal dihalide, we are talking about vicinal dihalide. Okay, and we are taking NaNH2, we are getting our alkyne by doing double elimination. Dehydrohalogenation you have done twice, that is all. Once you have already done, in which you get alkene, you will do the removal of HBr once again and you will get your alkyne. Simple. Okay. Byproducts you are not concerned with, they are also not concerned with, no one is going to ask you, so you don't have to worry about it. Okay, so these are the different ways in which you can prepare alkane, alkenes and alkynes. These are the important methods from where they will ask you the question directly also. Okay, see the next one. What else is there? Electrophilic aromatic substitution. What type of reaction we are talking about? ES, electrophilic aromatic substitution. We have aromatic hydrocarbons also, right? This is the most important reaction that you will find for your aromatic hydrocarbons, from where they will definitely ask you a question, and it is so simple to understand. You already know about that, but we are going to revise it. Okay, so electrophilic aromatic substitution, 3 steps are involved here. There are different types of electrophilic aromatic substitution. You can do halogenation, you can do nitration, you can do sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation also. And in all these different electrophilic aromatic substitution reactions, the only thing that you will change is electrophile. Rest everything, the entire mechanism is absolutely same. That makes it simple. Okay, that if you understand one mechanism, you just have to change the type of electrophile, you just have to remember the reagents, and you can write the entire reaction once again. So this is what we are going to discuss with a general case scenario, a normal electrophile. Then we are going to change the electrophile based on what reaction we want to do, and we can repeat the same process. Okay, so what are the 3 steps involved? So you will first generate the electrophile. So based on whether you are doing halogenation, sulfonation, nitration, alkylation, acylation, different reagents are used, different electrophiles are created. But let's say we know about that, we will cover that as well. You have generated the electrophile. What will the electrophile do? You have your aromatic ring, the simplest one. Let's take benzene. We will talk about substituents also later on. So benzene is electron rich, electrophile is electron deficient. So your benzene ring can attack the electron deficient species. That is the entire point of a chemical reaction. Someone who is electron rich will attack another species which is electron deficient. Correct? Okay, so generation of electrophile, it requires a Lewis acid catalyst, example AlCl3, FeCl3, sulfuric acid, based on what type of reaction you are doing. Okay, then it converts your neutral reagent into strong electrophile. These acid catalysts that you have taken, they will convert your normal neutral substituent into a strong electrophile, and if your electrophile is strong, the reactions will occur faster. Okay, so we are taking the example of nitration here. Then we will discuss the different other electrophiles also for the other electrophilic aromatic substitution as well. Okay, so we have taken nitric acid and sulfuric acid, and we have prepared nitronium ion. So this is our electrophile. Yes, this is our electrophile. Okay, we have generated the electrophile. What now? Then in the second step, your benzene ring will attack the electrophile. It will form arenium complex. That arenium complex or sigma complex, you can call it either one of these names, but you should know about it. So that arenium complex, why is it so stable? Because of resonance. And in the last step, you will remove your proton and you will get your substituted benzene. This is your electrophilic aromatic substitution reaction. So we are done with the first step. You have prepared the nitronium ion. Now let's take one benzene ring and attack this electrophile. So second step, attack of electrophile. Electrophile attacks the electron-rich pi system of benzene. It will form a carbocation intermediate that you can also call as arenium ion or sigma complex. Okay, so this is your arenium ion, this is your sigma complex. Why is it so stable? Because of resonance. Let me show you. This positive charge will be delocalized in the entire ring, will be stabilized because of that. So because of these resonating structures, this rhenium ion is stable, this sigma complex is stable. But we know the aromaticity is lost, right? In the beginning, you have benzene. It is stable because of resonance. In this case also we can do resonance, but aromaticity is lost. We want the aromaticity back. So hydrogen will do the ultimate sacrifice. Hydrogen will give back the electrons to the cyclic ring and you will get your aromaticity back. And that will be your final step. Please see. A rhenium ion complex made, carbocation intermediate formed. Finally, deprotonation. A base removes the proton from the intermediate. This is what you have created. So we don't have the aromaticity, we just have resonance. We want our aromaticity back. Okay. So this hydrogen will give the electron back to the cyclic ring. You will get your aromaticity and now your electrophile is substituted on the benzene ring. Okay. So you will get your nitrobenzene. So like that you can repeat the steps with other electrophilic aromatic substitution reaction also. The only thing that you will change is the type of electrophile and the reagent. Obviously the steps will remain same, the method will remain same. You will generate the electrophile, you will attack it and you will remove the proton. These are the 3 steps and this is how you proceed with the reaction. So what are the other different types of electrophilic aromatic substitution reaction? Please see that also. See, nitration we have already covered. Concentrated nitric acid plus sulfuric acid. This is the nitrating mixture. Do we have to remember the nitrating mixture? Yes, you have to remember the mixture. The reagents, otherwise how will you form the product? Obviously. Okay. Next, sulfonation, fuming sulfuric acid, or they may write oleum also, or they may write H2S2O7. This is the formula for oleum. So don't get confused that what are we supposed to do in this case. This is oleum. H2S2O7, it gives you sulfuric acid, so they may write that also, and it will give you sulfonation reaction. What will be the final product? Benzene sulfonic acid, SO3H, nitrobenzene. Whatever halogen they have given you, chlorobenzene, bromobenzene, depending upon what type of halogenation you are doing, bromination or chlorination. Okay, so you have taken Cl2 or Br2, FeCl3 or FeBr3 acid catalyst so that you can generate a stable, strong electrophile. Okay, see the next thing. Friedel-Crafts alkylation or acylation. Here you take alkyl chloride, here you take acyl chloride. Again with acid catalyst, so you will get alkyl benzene in this case, alkyl group. Or acyl benzene in that case. You can choose the alkyl group, it will come with the keto group. That is why we are calling it acyl benzene. Okay, so this is how you can do the 5 different types of electrophilic aromatic substitution reaction. The only thing that you are changing is type of reagent. Everything else is exactly same. Okay, see the next thing. So effect of substituents on the benzene ring. All such examples that you have taken, we were starting with benzene, right? What if there is a substituent already present on the aromatic ring? Then what should we do? Will that affect the products of the electrophilic aromatic substitution? It must. So it depends upon the type of substituent it is given. So what type of substituent can be given to us? Maybe it is electron donating group. Maybe it is electron withdrawing group. Depending on that, different types of products can be formed. So electron donating groups, we consider them to be activating groups. They will increase the electron density on your aromatic ring, and because of that, the reaction will occur faster and you will get ortho-para substituted product. What type of product? Ortho-para substituted product, and out of them, para will be your major, but you will get both of them. What type of groups we have talked about? Activating groups, electron donating groups. They will increase the electron density on the aromatic ring, they will increase the reactivity of the ring, and they will give you ortho-para substituted product, and the para product will be major. So these are some of the examples. Like that, they can give you anything. You have to choose whether it is activating or deactivating. How will we choose? You have learnt about electronic effects, everyone, in the last session. In GOC, we have learnt about plus I effect groups. We have learnt about plus R effect groups. So you already know about activating and deactivating group. You know them as electron donating and withdrawing groups. It is the same exact scenario. Okay. So they will make the reaction go faster. Highest, they will ask you the question, they will give you different types of substituents on your aromatic ring. They will ask you to arrange them in increasing or decreasing order. You can answer that also based on the type of group which is attached. As simple as that. Okay. See the next thing. What if it is a deactivating group, a electron withdrawing group? In that case, it will decrease the electron density of your aromatic ring. It will decrease the reaction rate. And in this scenario, what type of product you will get? Meta-directing product. So only one type of product, yes, and that also at meta position. So this is all about the type of substituents which are attached, how they will decide the type of product that you are forming. Okay, see the next thing. So now we are done with the content. We are going to solve question. Do we remember cool-based electrolysis? We have just not discussed it. I have told you the entire steps. Now I hope you can answer this question easily. Okay, let's see. So in cool-based electrolysis of sodium propanoate, first of all, you have to write the compound. They are not giving you the formula. We have to decide ourselves. So propane is the word root. So it must have 3 carbon atoms. That is how you will remember it. And in these 3 carbon atoms, one would be your carboxylate group, obviously, because we are talking about some acid. Okay. So this is how we can write it. CH3, CH2, COO minus. So this is my starting material. We are doing cool-based electrolysis. So we are going to do decarboxylation and we have to form some hydrocarbon. You have learned this entire reaction just now, in which I have given you the steps. I have told you what happens at anode and cathode. I hope you can answer it now. Okay. So what will happen at anode? Hydrocarbon will be formed, right? Oxidation, loss of electrons. You will form free radicals and CO2 gas will be liberated. Now these free radicals will combine to give you hydrocarbon. So how many carbon atoms are present in your hydrocarbon? 4, right? See the options. 2 carbon atoms. 3 carbon atoms, 4 carbon atoms, okay, could be our answer, 4 carbon atoms. But see, the products at anode and cathode. This is the reaction at anode, right? See, if you know the products, let's say you know the reaction, you have done everything correctly, but you don't remember whether the reaction to give you hydrocarbon occurs at anode or cathode, you can give the wrong answer in that scenario also. So please read the question carefully and please remember the fact the hydrocarbon formation occurs at anode. What happens at cathode? Hydrogen gas will be liberated at cathode along with NaOH if you are taking sodium, KOH if you are taking potassium salt. Okay. So at anode we will get hydrocarbon, at cathode hydrogen. That is why C is the correct answer and not D. Okay. Please read it carefully. Don't answer in a hurry. I can see hydrocarbon H2. This must be the correct answer. No. The reaction to form hydrocarbon occurs at anode. H2 gas will be liberated at cathode. Okay. See the next question. A mixture of ethyl iodide and N-propyl iodide is subjected to Wood's reaction. I told you they will definitely ask you a question on Wood's reaction, and that is very simple. You will just remove the halogen atoms, combine the alkyl groups together. One more thing that I have told you, that in Wood's reaction, we try to make symmetrical alkane because in that scenario, the percentage yield is great. But if you take unsymmetrical alkane, you start with 2 different types of alkanes, you will get the product. Percentage yield will be less. So this is one such question in which they have taken 2 different types of alkane. Let's see what type of products we will get. A mixture of ethyl iodide, CH3CH2I, and N-propyl iodide, see, two kinds of alkyl halide we have taken. We are doing Wood's reaction, so sodium and diether. See, we will get three different types of products here. You start with one kind of alkyl halide, okay? So this will give you, if they react with another molecule of ethyl iodide only, it will give you a symmetrical alkane with 4 carbon atoms, okay? So you will get butane. If it reacts with another molecule of ethyl iodide, is a possibility, will definitely form butane, okay? What if this molecule reacts with another molecule of N-propyl iodide? So we are doing self-Wood's reaction. So in that case, we will form hexane, okay? Okay. But since we are taking two different types of alkyl halides, they will react with each other also, right? So in that scenario, what can get formed? I have 2 carbon atoms here, 3 carbon atoms here. I will get pentane also, okay? If we do the cross reaction. Okay. Can I get anything else? No, I have written all the possibilities. We have formed butane if this particular alkyl halide reacts with another molecule of ethyl iodide only. We have formed this product if N-propyl iodide reacts with another molecule of N-propyl iodide. We have formed this also if we do the cross reaction. There is no other possibility. Now see what they have asked you in the question, that which product is not likely to get formed. So I can definitely make pentane. I will definitely get hexane, I will definitely get butane, not very high E because you are forming 3 different types of products. But still, you will receive these 3 products for sure. What you will not get in this particular reaction is propane. This was the question. The hydrocarbon which will not be formed is propane, because we have written all the possibilities. That is why we don't prefer Wood's reaction. If you want to prepare an unsymmetrical alkene with odd number of carbon atoms, because it gives you a lot of byproducts, and if you form byproducts, your percentage yield comes out to be low. This is one drawback that you have to remember for Wood's reaction. Okay, see the next question. A dibromide C4H8Br2 on dehydrohalogenation, beta elimination, that we have learned about in the beginning. And since we are talking about Br, so we are going to remove HBr, gave Y, which on reduction with Z gave non-polar isomer of C4H8. What are X and Z respectively? So we are doing dehydrohalogenation. Everyone understands that. Okay, we know it, alright. And then it undergoes reduction with some reagent, we don't know, Z, that gives you a non-polar isomer of C4H8. First of all, please understand, you will form from X some alkyne, right? Double elimination, remember, we have learnt about it. By double elimination reaction, dehydrohalogenation, if you do it twice, you will get alkyne. So we are doing the same thing here, alright. So you will get this alkyne. Now you have to choose if you want to prepare some non-polar isomer, some alkene you are preparing, because we are doing reduction. Which alkene is non-polar? Will it be cis alkene or trans alkene? Non-polar, in which you have some dipole moment. Right? And if you take trans alkene, dipole moment will come out to be 0. It will become, okay, we are talking about non-polar. So dipole moment is 0. I am so sorry. We are talking about non-polar. So non-polar, dipole moment is 0, right? So in the end, You have to choose between cis and trans alkene. If you talk about cis alkene, it will have some dipole moment. It is polar. But if you talk about trans alkene, it is non-polar. It will not have any dipole moment. So in the end, what type of alkene you will prepare? You will prepare trans alkene. Now the question arises, which reagent we should take? Sodium in liquid ammonia or palladium with carbon? See, palladium with carbon, if you take with your alkyne, it will give you cis alkene. But if you start with sodium with liquid ammonia, it will give you trans alkene, which you want to prepare. So which reagent we will use? Sodium with liquid ammonia. Okay. It gives you trans alkene. And it will have zero dipole moment. That is why we are calling it as non-polar. Why are we not choosing these two? We can get an alkyne from here also. But they have asked you to prepare some final product which is an isomer of C4H8. So I must have 4 carbon atoms in the final product. Isomers, they have the same molecular formula, but the properties are different. So my molecular formula must be same. I must have 4 carbon atoms. In this scenario, you will get 5 carbon atoms. So you can eliminate option C and D from the beginning itself. Okay. The question was between A and B, and how we have eliminated B, because palladium will give you, it will do the reduction. It will give you alkene from alkyne. But what type of alkene will you prepare with palladium? You will get cis alkene, which is polar. Okay. So your correct answer is option A. Alright, so that is how you have to solve the question. You have to read all the steps carefully. So now what is the important piece of information that you will remember? That if you want to prepare trans alkene from alkyne, you will use sodium in liquid ammonia. If you want to prepare cis alkene, you can use PDC, or you can use Lindlar's catalyst also, H2PDC BaSO4, that will give you cis alkene. You have to remember that. Can be asked directly like in this question. Okay, see the next one. An alkyl halide C3H7Cl on reaction with the reagent X gave you some major product Y, C4H7N. Y on hydrolysis released a gas which turns red litmus blue. So this is a property of acid, right? It turns red litmus blue. Okay, so what are we trying to do here? Please see. You are starting with some alkyl halide that reacts with some reagent X and gave you some major product Y with C4H7N as the formula. So you started with some alkyl halide. You reacted it with, we don't know, maybe potassium cyanide, maybe with silver cyanide. Please remember, we call them as, in this case, you get different products if you use KCN and AgCN. If you start with KCN, you will get cyanide. If you start with AgCN, you will get isocyanide. So we all understand this can't be formed with KCN and this can't be formed with AgCN. So option number A and C are removed. You can get cyanide with KCN and isocyanide with AgCN. So we have to choose between B and D. Now how to choose that? If you are getting on hydrolysis some gas which turns red litmus blue, we are forming some type of acid. Okay, and if you form a cyanide from here and you do hydrolysis, you will get carboxylic acid. So this must be my final product. So this must be my starting alkyl halide and the reagent X must be KCN. So my correct answer will be option B. Option D is eliminated because it will not give me that carboxylic acid. From cyanide on hydrolysis, I will get the carboxylic acid. So that is how you have to solve it. So another concept that you have learned right now, that if you do the reaction of alkyl halide with KCN, you will get cyanide as the product. If you do the reaction of your alkyl halide with AgCN, you will get isocyanide. Remember that now. And cyanide on hydrolysis gives you carboxylic acid. We have done the same thing here. Alright, see the next question. The alkane which is next to methane in the homologous series. How do we write homologous series? You just add CH2. Okay, so if you are starting with methane and you want to see what is next in the homologous series, you will add CH2. So ethane, right? So you want to prepare ethane, you just have to see which reaction will give you ethane. Okay, so let's see which reaction will give you ethane. What's the reaction? For sure. This is giving me ethane. Okay, this is fine. Decarboxylation reaction. NaOH, CaO, heat, soda, lime you have taken. It will give you decarboxylation. What is decarboxylation? Removal of CO2. Okay, so what will be the product? You will get. So is it ethane? No. We have to form ethane, right? So this can't be our answer. Okay. We are doing reduction of this alkene. Reduction, addition of hydrogen from alkene, you will get alkane, obviously. Okay. So what will be the product here? You will break this pi bond and you will add hydrogen on both carbon atoms. So you will get propane. We want to prepare ethane, not propane. So option number C is also incorrect. Okay. What about, reaction number 3 is also incorrect. What about this one? We are doing reduction of alkyl halide. We have learned this thing. Reduction of alkyl halide with zinc in the presence of HCl will give you alkane, hydrocarbon. Okay. So what hydrocarbon you will get here? Ethane. Is this correct? Yes. So first and fourth are your correct reaction. Correct answer is option A. And you are done. Okay. So if you know the preparation of alkanes, alkenes and alkynes that we have covered, you can easily answer this question. Only 3-4 reactions we have done. And based on those 3-4 reactions, please see how many questions have been asked. And they are repeated multiple times. Okay. See the next question. The correct order of boiling point. Please understand how do we compare boiling point, and you can apply this information to other different types of compounds also. It depends upon molecular mass. If you have high molecular mass, you will have higher boiling point. What if molecular mass is same for 2 compounds? Then how should we prepare? How should we compare? So if molecular mass is same, you will compare based on branching. If you have a linear chain, high surface area, van der Waals forces of attraction are stronger, your boiling point will be higher. But if you have branching in your chain, surface area decreases, van der Waals forces of attraction also decreases, and your boiling point also decreases. So 2 things we will compare. Directly proportional to molar mass. This is the first criteria. First compare the molar mass. If molar mass comes out to be same, then and only then compare the branching. Because if branching increases, the surface area decreases, and if surface area decreases, van der Waals forces of attraction decreases, and your boiling point also decreases. So your first thing that you will check is how many carbon atoms are there. More number of carbon atoms, more molar mass, more boiling point. Okay. So please see, you have 6 carbon atoms here. 2-dimethyl butane, 6 carbon atoms here also. 2-methyl pentane, 6 carbon atoms here also. So molar mass is not changing. These 3 are isomers of each other. Then how should we compare? So I told you, please compare molar mass first. If molar mass comes out to be same, then please look for branching. Okay. If branching increases, your boiling point will decrease. Okay. So this is a linear chain. This will have the maximum boiling point. In this case, you have 2 side chains. Boiling point will be least. In this case, you will have 1 side chain. So your correct answer is option A. Okay. So you have compared the molar mass. If molar mass came out to be same, then you have compared the branching. Branching increases, branching increases, boiling point will decrease, and that is how we come to this relationship. Option A, and you are done. Okay. See the next question. Identify the starting compound P in the following reaction. See, we are doing Wood's reaction, and I told you they can ask you this question from Wood's reaction, and in which they will give you the product and they will ask you the starting material. How will you answer this question? The simplest question they can ask you. Wood's reaction is used for the preparation of symmetrical alkane. I told you about this thing. It will give you high percentage yield of symmetrical alkane. So if they ask you what is the starting material, which alkyl halide you have started with, you will just break your final compound, the product, in 2 equal halves and attach it with your halogen on both sides. So what are the two things you will do? You will break down your alkane final product into 2 equal halves and you will connect them each with your halogen and you will get your starting material. That is your entire question. Let me show you. This is your final product, right? Is it symmetrical? It is symmetrical. So if I want to break this in 2 equal halves, I will break it from here, right? I have broken my final product into 2 equal halves and I will connect them both with some halogen, okay? Which halogen they are talking about? They are giving you bromo in the options, right? Connect them with bromine. So you will get 2 sets of these alkyl, right, which have gone the Wood's reaction, which have undergone the Wood's reaction, and they have given you this final product. So what is the name of this compound? 2-methyl 1-bromo propane. 2-methyl 1-bromo propane. We have to write it in alphabetical order, that is why bromo comes first, right? B comes before M. So 1-bromo 2-methyl propane. This is your starting material that gives you this final product. So like that, they can give you any particular final product. You have to follow the same thing. Break it down into 2 equal halves, connect them each with your halogen, and you are done. Okay. See the next question. Which of the following alkenes does not undergo Anti-Markovnikov's addition of HBr? See, if we are talking about Markovnikov's or Anti-Markovnikov's addition, it is done on, first of all, unsymmetrical alkene, and you have to take unsymmetrical reagent also. So the reagent is unsymmetrical, I can see that. It is HBr, not H2, not Br2, HBr, unsymmetrical reagent. So I want unsymmetrical alkene also. If the alkene is symmetrical, you don't have to choose. You will get the same exact product from Markovnikov's and Anti-Markovnikov's addition. So if they are asking you which particular alkene will not give you Anti-Markovnikov's addition, they are just trying to check your knowledge, whether you know in which scenario you have to do this Markovnikov's or Anti-Markovnikov's addition. We are looking for some unsymmetrical alkene. Anti-Markovnikov's addition. So if you have a symmetrical alkene, it will not give you this Anti-Markovnikov's addition reaction. Please see. This one is unsymmetrical. This will give me Anti-Markovnikov's addition. But 1E. Yes, but 1E, that is also unsymmetrical. So this will also give us Anti-Markovnikov's addition, not the correct answer. 2-butene. This is symmetrical, everyone. So if this is symmetrical, you want to do the addition of HBr in the presence of peroxide, in the absence of peroxide, you will get the same product. Markovnikov's addition, Anti-Markovnikov's addition, you can do either one of them. You will get the exact same product if you start with a symmetrical alkene. So this is my correct answer. This will not give us Anti-Markovnikov's addition with HBr. That was the entire question. Okay, see the next one. consider these reactions and find out the final product Z. So first of all, we are doing reductive ozonolysis. And what happens when we do reductive ozonolysis? You will break the pi bond of the alkene system. You will connect the two atoms with double bonded oxygen. Since it is reductive, you don't have to do over oxidation. So your final product will be aldehyde or ketone. Okay. So I will break this bond. Great. I will form these two products and HCHO. So these two are formed. Now what is the second set of reaction they have given you? In the presence of dilute NaOH and heated it. So they are asking you to form the product by aldol condensation. Okay. So second step is please see how do we write the product for aldol condensation. I will tell you how to write the product directly also. It is very simple. Okay. So you will form alpha beta unsaturated carbonyl compound. If you can find the answer from that also, your part is done. Okay. What we will form? Alpha beta we are doing aldol condensation. Okay, so in aldol condensation, you will form an enolate first. In order to form the enolate, you must have some alpha hydrogen. Otherwise, how will you remove the hydrogen? Obviously. So we can form the enolate from acetone. HCHO will not give you any type of enolate. So you can leave that. Okay, so you will form the enolate. You have taken the base. It will abstract a proton. So this is the enolate. It will attack your carbonyl center, which is electron deficient. Okay. And you will form beta hydroxy carbonyl compound. Now if we are given heat, right? So there will be elimination of water. We are doing beta elimination once again, and you will get alpha beta unsaturated carbonyl compound like this. So from here you will remove proton, from here you will remove OH, and you will get this product. Alpha, beta, unsaturation is there, alkene system, carbonyl compound. Alpha, beta, unsaturated carbonyl compound if you have the proton available. If you have only one alpha hydrogen, then the reaction will stop here on your beta hydroxy carbonyl compound. If you have at least two alpha hydrogens and you do aldol condensation, condensation is this, loss of water. If you want to call it as aldol reaction, you will stop the reaction here. But since they have given us heat in the question, you will form the final product, the alpha beta unsaturated carbonyl compound. So what will be your correct answer now? Okay, let's name it. So you have a keto group at the second position, and at the third position you have the alkane. Okay, so butene you will give the preference to your Feinstein group. It will take precedence, so you will start the numbering from that side. And you have the alkene system also, so you have to include that also in the parent chain. Okay, so this is your alpha beta unsaturated carbonyl compound. This is your final answer. That is how you have to proceed in aldol condensation. Obviously, you don't have to show them the entire mechanism, but you should know about aldol condensation. Again, a very important name reaction, and we have covered that in oxygen containing organic compounds. Okay, see the next question. What is the major product Y in the given sequence of reaction? Okay, so you have some alcohol, you have added concentrated sulfuric acid, so we are doing dehydration, loss of water, beta elimination reaction, so your X is some alkene, and now that alkene reacts with HBr in the presence of peroxide, so you will form some Anti-Markovnikov addition product. Okay, in the presence of HBr and peroxide, Anti-Markovnikov addition. Okay, so you have formed the alkene, this alkene. This is your X. Since we are doing Anti-Markovnikov addition, we will form less substituted alkyl halide. So this will be my final product. Which one? This one. Option A. If you do Markovnikov addition, then you will form more substituted alkyl halide. In that scenario, your bromine will come on the second carbon atom. In this case, you are forming less substituted alkyl halide. So that is the difference between Markovnikov and Anti-Markovnikov addition. And how do we decide whether it is Markovnikov or Anti-Markovnikov? If you see HBr present with peroxide, not HCl, not HI, HBr present with peroxide, we will do Anti-Markovnikov addition. Okay, remember that. Alright then. So, do we have any questions? Yes, VT, you can do this portion for your TS exam also. I am covering both parts. Okay, AP and TS both. Don't worry. Alright. Okay, let's see one last question. Then we will end our session. Identify the major product P in the following reaction sequence. So you are starting with some alkyl halide. In the presence of alcoholic KOH and heating it, you will form some alkene beta elimination, and that will then undergo Markovnikov addition to give you some alkyl halide once again. Okay, so this was your starting material. You have done beta elimination. And once again you have done Markovnikov addition. Markovnikov addition. So you get the reactant back. Okay, we have formed the reactant once again by doing the sequence of reaction. So your correct answer is this one. Option A. Okay, so that is how you have to proceed. So what we have learned so far? We have learned about the reactions of alkane, alkenes, alkynes. We have also learned about electrophilic aromatic substitution. Now we will end the session here. We have plenty of other questions that you will find in the PDF. You can see it on our Telegram channel. If you have doubts, you can ask us in the comment box. We will tell you. And this entire session is both for your TS and AP syllabus. So don't worry too much about it. Okay. So I hope this is fine. And one more thing, in the next session we will continue with amines, another organic chemistry chapter. So please join and please solve more and more questions. If you practice more, you will learn more and you will secure good marks. Okay. One more thing that I wanted to share with you. One last thing. Yes, if you have brothers or sisters who are studying in grade 3 to 10, then they can enroll in our 1-year maths program For 1 year only, we are giving it to you at just rupees 999. Very cheap. Per day you will find the cost is even less than 3 rupees. And we will cover the entire CBSE, ICSE and state board syllabus, and all IIT and IT teachers will be teaching you. You can download our app, you can look for other programs also, and you can take help of Sysya AI also if you enroll for this course or any other long-term course. Okay, so with the help of Sysya AI, you can ask your doubts, text to text, speech to text, image to text, and this course is going to start from 5th May. So enroll and please study from your IIT and IT experts. Okay, so that is all for today, everyone. Thank you so much for joining the session, and please join tomorrow. We are going to learn about Amaze, and if you have any doubts, you can ask us in the comment box. Thank you so much, everyone. Have a great day. Bye, everyone.